In our unique testing setup, we subject shafts of varying infill densities and unique geometries to torsional loads as well as 4-point bending loads simultaneously.
This experiment replicates the real-world conditions that shafts typically face in machinery and aerospace applications.
We gather data on stress distribution, deformation, and fatigue characteristics with the goal of pinpointing areas for design improvement in the shafts as well as our setup.
We'll now show you the processes to design, build, and execute the experiment.
In developing our test stand, it was important that everything fit together as specified in the assembly, with the bearings being aligned properly and being low in friction to ensure smooth and consistent rotation of the shaft. This took multiple iterations and print settings to get right. The motor is attached using a coupling mechanism that allows for precise rotation. The stand features a modular design for easy assembly and disassembly, ensuring quick setup for different specimens. Each element is designed to maintain uniformity across tests, enabling reliable data collection and valid experimental comparisons, as well as a fast setup time.
During the stand assembly, we encountered several challenges with the bearing and shaft tolerances, as the fitment of the bearing onto the shaft was incorrect, as well as the fitment of the encoder wheel onto hexagonal shaft. The only thing we needed to do was make the hole in the bearing moderately larger and sand down the encoder wheel.
The beam in our experiment is loaded using a 4-point bending setup, which was chosen to isolate the bending stress within the central region of the beam. To do this, we wrapped string around the 2 central bearings and loaded different weights to test different stress conditions.
During the experiment, the LCD and serial monitor allowed the group to monitor the number of cycles, the rotations per second of the shaft, and the applied load to the beam. After running the experiment for 1+ hours, the data stored in the SD card was analyzed by looking at the number of cycles and time elapsed at failure, as well as making graphs like total cycles versus time.
In our project, electronics and sensors are crucial for system control and data collection. An LCD screen connected to an Arduino Nano displays essential data such as total cycles and time elapsed, with brightness adjustments made through a potentiometer. We faced challenges like a faulty micro USB cable, which we resolved via troubleshooting with the Arduino IDE to confirm the hardware issue. The encoder wheel and optocoupler subsystem, designed for precise cycle measurement, required adjustments for practical implementation, including a swing mechanism designed by Evan, which allowed for easy specimen swaps in between tests. Motor speed is regulated via a motor controller linked to a DC power supply, allowing variable test conditions for structural beams. The microSD card subsystem, outlined with detailed steps for file creation, reading, and writing, was integral for storing experimental data, which can be accessed and verified through a menu on the Arduino's serial monitor.
Throughout this process, we learned many key lessons, a couple being the value of iterative testing and integration.
As we progressed from the initial subsystem tests to full system integration and further X labs, it became clear that early and frequent testing of each component allowed us to identify and address issues before they impacted the broader system.
This process of troubleshooting isolated components allowed us to thoroughly understand each step of the process and the failure points of each component. Doing such allowed us to minimize disruptions and facilitate a smoother final assembly, as shown by our successful shakedown tests, where the entire system was operational for hours without any major issues.
In the future, we think that the build quality of the testing setup could be improved to industrial-grade materials, especially on critical components like the bearings, which would allow for extended testing and ease of use.